Today's live session follow-up video has two important goals. First, we want to define function handles in Matlab. This is an important class of objects that we'll be using quite frequently throughout the rest of this course. Second, we want to use Matlab's built-in ode45 solver to solve the first order IVP y prime equals t minus y with initial conditions y of 0 equals 1. To better understand how function handles work, I think it's worth taking a step back and recalling how Matlab's built-in functions work. So if we wanted to compute something like e squared or sine of pi, then Matlab already has built-in functions e and sine, which would allow us to compute that task in a couple simple lines. But if I want to create a function x squared which kind of behaves like these, that's where function handles really come into play. The syntax for a function label is on the left. Before the definition, you want to state what you're going to call that function. For now, I'm just going to call this one f. The second part of a function handle definition is the inputs that you're going to accept. Matlab has kind of a funky notation. If you're used to like lambda notation in Python, this might not be so odd for you. If not, then well, it might take you a little while to get used to. But this @x is basically saying that in this function f, I want x to be defined as a variable. After the @ symbol and the variable name in parentheses, you just state the definition of the function. So in this case, x squared. So if I run that command in Matlab, you'll notice that Matlab has now defined f as a function handle. And so now if I want to compute 2 squared, for example, I would just run f of 2 and it shoots out the answer 4. Similarly, we can define functions of more than one variable. For example, if I wanted to define a function of x and y, which took x squared and added to that y squared, then I would just add x and y both as inputs into my function handle definition. And then the format I would use would be something like f of 2 and 3, which would give me 2 squared plus 3 squared. If you understand how those function handles work, especially the function handles with 2 input arguments, then it's a pretty easy jump to understand how to use ode45. The first argument in this function, you'll see when you pull it up, is ode_fun, which is a fancy name for the rate function of the differential equation you'd like to solve. Now our rate function, recall, was t minus y. So to enter that as a function handle, I would enter @ty t minus y. So now I'm defining basically the right-hand side of the differential equation I'm trying to solve. The second argument, you'll see t-span, is the interval of time values on which you want to solve this differential equation. We obviously want to start at 0 since we're given an initial condition at that time. The upper limit will probably vary from problem to problem, but I'm just going to use 5 for now so we get a good view of our solution. And the final argument, which is important to note, is why not, the actual initial condition given in the problem, which here was 1. So if we run that command, you'll notice that a figure pops up, both in your live script and outside of it. And this figure shows an estimate of the solution to the differential equation over the time interval that you've specified. And we can see it looks similar to what we saw when we ran Euler's. Now, one of the primary places where we'll use ode45 throughout the semester is in validating solutions to differential equations. Validation basically means you have an alternative method for checking that what you did by hand wasn't just some bullshit algebra, that you actually did your work and got a correct answer to the problem at hand. So let's look back at this pretty simple differential equation, one we solved the first day of class. The IVP y prime equals y, y of 0 equals 2, which we already know has the solution y of t equals 2e to the t. Let's say though that you didn't know this, you had done some crazy math and gotten this answer and you want to check that it's correct. Well, the first thing we're going to do is we're going to enter this differential equation into ode45, this initial value problem into ode45, and store the solution as two variables, t, the vector of times that Matlab used, so basically the vector of times that were plotted in something like this above, and the actual values of y that were plotted on the y-axis in this plot above, of course, with this different differential equation. So to store the output of ode45, we're going to start a little differently. We're going to define the time vector of outputs as t, and the vector of actual solutions to the differential equation is y. Values of the differential equation solution is y. And then we just run ode45 before. And I want to point out here that even though our rate function in this problem is just y, it doesn't involve t, you still have to define the rate function as a function of these two variables for ode45 to work properly. What time interval are we going to use? I'm going to use 0 to 10 in this case, and our initial condition is now 2. I don't want to see these solutions. They're just going to be these really long vectors. So now when we run this command, we'll see the plot go before, and now we'll have those two vectors t and y stored for future use. So the next step is I want to create the plot above, essentially, but I want to compare it with my actual solution, which was 2 times exp of t. And I'm going to plot that one using black lines. So this plot now will show both the ode45 approximation, the solution we got by hand, and if they match up, yay, we did a good job. And sure enough, if you look at this plot, the black line goes right through those blue dots, and so it looks like we validated our solution to that differential equation. So from henceforth in the course, anytime you see a problem that says validates your solution using Matlab, this is the type of thing you want to do. Of course, if it was a homework problem, I'd also ask you to label the axes, put on a legend perhaps, that type of stuff. But you already know how to do that, so we'll end this video here and let you get on to the quiz and homework for the day.